What you are seeing right there on the board is what we call circular what? Motion. It's called circular motion. What we are trying to show here, we have different types of motion. We'll talk about the types of motion like translational motion of the body moving in particular parts. That's what we call translational motion. Then we talk about rotational motion. Then we also talk about oscillatory motion. Yeah, circular motion is like something like this. Rotational motion performs a circular motion. What happens here? We are going to be talking about some parameters that are not common in our linear motion. First of all, we will see that this X here is like an arc. You check my video, I've talked about an arc before. A portion of the circumference is an arc. And this X here is just like the length of an arc here. We are going to show the relationship of these formulas, how they are. In fact, I'll bring out formulas that are very relevant in this circular motion. Now I'll start with the first one, which is our angular velocity, angular speed is equal to, that is angular velocity, which is represented with what, W, is equal to angular distance over what? Over time. Angular distance over what? Over time is what? Just like we have in our linear velocity or linear speed, we say distance over time. But this one is angular distance. That one was distance for normal speed. But this one we are talking about what? Angular what? Distance over time. Angular speed or angular velocity. We use them interchangeably. Then the next thing is we have other formulas. Don't forget, before now we also know that this angular, if we derive it, we will see that this angular speed is also what? 2 pi times frequency. That F there stands for what? Frequency. 2 pi times what? Frequency. This is also the formula for angular. We use this formula in so many places, like wave. We use this angular velocity here because all this have to do with wave patterns. I mean, in terms of moving in particular, completing circles, movements, circular motions. Then we also have it in alternating currents. We have it in so many areas, even in magnetism and many other topics. We make use of all of this there. So we have, it's a relevant topic for us because we are going to use them to connect other topics. Here we go. We have this formula. Don't forget, we also have a formula that gives us a relationship. This you are seeing here is acceleration. We call it centripetal acceleration, which is equal to what? The square of the linear velocity over radius. Square of linear velocity over what? Over radius. And we also have other formula relationship. Please, there's something I've not emphasized here, which is what we call the AC here, which we call centripetal acceleration. Centripetal acceleration is the acceleration that is always directed to the center of that circle of that motion. Directed to the what? To the center of the circle of that. The acceleration, not force. We have centripetal acceleration, and we also have centripetal what? Force. But where we are now is what? Centripetal acceleration. So that is just take this formula. Then we also have a relationship. We have a relationship between the linear speed and what? Angular speed. That formula that gives us this is the linear speed, linear, just like in a straight line. Then radius times what? Angular speed. Radius times what? Angular speed. In fact, we also have a formula that relates our linear distance with angular distance. That is what you are having as S, like the length of an arc here, is equal to what? Arrow times what? Angular. You can see the relationship here. This is our linear distance times what? Radius is angular distance. But the whole thing here is that this angle, it is not in degree, it's in radians. In fact, that's why our unit, the angle we are using here, most of these times is in what? We convert it to what? Radians, not in degree. That's why our unit for angular speed is actually what? Radians per seconds. The unit for, because the angle we are using there, we're not using it in degree, we are using it in what? In radians per what? I mean in radians. So now rad per second as the unit of what? Angular speed. You have a question? Can you ask a question? What's the question? Okay, so let's go on. We are just showing the formulas that are relevant. Now we want to tell you another formula of angular, centripetal acceleration rather. If we substitute this term, don't forget, we are going to square it now because it's squared all over radius. What we are going to arrive at is what? R squared W squared over what? Radius. When you divide it, one arrow will remain there. So now our arrow W squared. So what we are saying is that our centripetal acceleration is equal to linear velocity square over arrow, or arrow times what? Angular velocity square. So either of this formula is what we call the centripetal acceleration. In fact, we also have what we call tangential acceleration, but I don't want to bring it here now. Tangential acceleration, what you are seeing, there's acceleration like that, this tangential. When you tangent, the line that touches the circle is tangent. And another thing that I need to say about this circular motion is common with exam questions. They will tell you that when a rope is twined, when the rope, maybe an object is tied to a rope and it's twined, it's wheeled. That is W-H-I-R-L-L-E-D, wheeled. This is what we're talking about. When it's wheeled. When it's wheeled. This is how the body uses. And that object cuts. In what direction will it move? It will move in anywhere it cuts. It will move tangentially to the direction of the circle. Do you understand? It will, if it cuts like this as it's moving, and it cuts like this, it will move tangentially. If it's like this, it cuts, it will move tangentially. Do you understand? So this is how anywhere, if you maybe the object, you are turning the object, it's moving like in circle, and the object cuts from this place to move tangentially. So it's an example question. I'll present the questions like that. So when an object is circle, if it's maybe suddenly cut off or move out of the circle, it will move what? Tangentially, in a tangential path. In a tangential what? Path. So that is exactly what we'll talk about. We have so much to say about this topic as we go. We are going to solve questions that are related to this. Then I talked about something here that this angle, we don't use it in degree. We use it in what? In radians. I derived the formula, which I don't know, maybe it can be in any textbook, that we can use to convert. How do we do that? 180 is equal to pi. So whatever degree we want to convert to, we can convert. For example, now I'm having 60 degrees. I want to convert it to rad. It's equal to what? S. This is radian. S what? Rad. If you check my unit conversion, I've given a video on that. Unit conversion generally, because I have a video on how to convert from one unit to another. If you know the relationship between that two things you are converting, this is in degree. This one is in degree, this one is in rad. I've given a relationship that 180 is equal to what? 1 pi rad. So what remains there is just calculation. I can convert any degree, whether 100 degree to what? Rad. Based on the relationship that 180 degree is equal to what? 1 pi what? Rad. I can convert any degree to rad. So let's do the one that we have here. See the relationship I gave you first. Now my interest is 60 degree. Assuming 60 degree. 60 degree, I want to convert to rad. See what I will do. I will now say 60 equal to what? S rad. So then I'll multiply. I will not carry the unit alongside with it. So I'm now having S times 180. I'm now having 180S equal to what? 60 pi. Because multiply, that is 60 times pi. Divide both sides by the coefficient of x, which our x becomes what? 60 pi over what? 180. When we reduce the fraction, we are going to have 6 here. 60 will go to rise. 0 cancel 0, 1 here, 6 here, 1, 6 here, 3. So now pi, 1 times pi is pi. Now what? Pi over what? 3. Telling us that, don't forget, 60 pi is equal to what? Sorry, 60 degrees is equal to what? 60x now, I've gotten x now. 60 degrees is equal to what? Pi over 3 rad. That's what we are saying. 60 degrees is equal to what? Pi over what? Over 3 rad. Because it's a conversion. So, although I just derived this when I was calculating, I just find a means of calculating. That's how I derived this. It could be in a textbook, I don't know, to be honest. So this is exactly how you can convert from any degree to what? Radian, because that is what is used. Yeah, we don't use it in degree. So in our next video, we are going to do some calculations on circular motion.